Here's what we're going to be able to answer before we walk out the door today. I got my sine ratio, opposite over hypotenuse, and I have my cosine ratio, adjacent over hypotenuse. When are they equal to each other? All right, when are they going to be always equal to each other? So let's examine that first. Actually, I don't care. I know I'm not worried. All right, first thing, take my right triangle ABC. Let's find the sine of A, the ratio that belongs to sine of A. First of all, what do you know about sine? How do I find it? Forget my letters. How do you find sine? 22, how do I find sine?
You find the length of the opposite.
Yes?
And the hypotenuse.
Thank you. Opposite over hypotenuse. So can you guys please do that right now? Sine of A, using my variables, please. The sine of A using my variables. And that ends up being 5 y over z. Good job. All right, honors kids, I have a challenge for you and your group. Can you find something else that is also equal to y over z? Like sine, cosine, tangent, maybe coming from a different angle, that's also equal to y over z. That's what you're in charge of for the next part. Find something else that's also equal to y over z, but not sine of A, of course. Find something else. Find something else. Talk to each other if you need to. Find something else that is equal to that. All right, what do you got? What else is equal to y over z up here? Oh, 15?
Cosine C.
Yeah, cosine C. If anybody finds cosine C, it's also equal to y over z. All right, so here's what we just found. Whoa! The sine of angle A has the same value as the cosine of angle C. Wow, that's interesting. There's got to be something going on with A and C then, if the sine of one equals the cosine of the other. So look at go back to the diagram. Is there anything I could say confidently about angle A and C? You can't say confidently that they're congruent. I have no idea. But there might be a little geometric fact you can tell me about A and C. Got anything, Dylan?
Less than 90, so they're acute.
They are acute. You are 100% correct. I want more, though. I want more than they're acute. John?
They add to 90.
Everyone agree with that statement? They add to 90. So give me a big boy, big girl vocabulary word. They are? Complementary, yeah. So what's so special about them? They are complementary. So here's the big fact for today. Big fact. If, and again, I'm just going to make up, this has nothing to do with the diagram. I'm going to put if angle A and angle B are complementary. Substitute in any letter you want. X and Z, Y and F, H and J. It doesn't matter. Whatever two angles you want. If angles A and B are complementary, then the following is true. I'll wait till you guys, so you guys focus in here. If you know two angles are complementary, the sine of one of them will always be equal to the cosine of the other angle. Always. The sine value of one is equal to the cosine value of the other. And again, could I switch B and A here? I could switch B and A and it's still true. As long as A and B are complementary. Okay, they have to be complementary for this to be true. Cosine of one equals the sine of the other. Got your calcs? Let's get those out if they're not already. So I can show you this using actual numbers. Because I think it's pretty vague right now what I wrote up there, and I want to show you with actual numbers. All right, so I got cosine of 20. Everyone plug cosine of 20 in your calculator. I'll do it with you. So cosine button of 20. That's that sloppy looking decimal up there. Here's what I need your help finding. What else equals this decimal up here using sine, cosine, tangent? All right, so the cosine of 20 has the same value as blank. All right, so let's try to use what I just showed you. Cosine of 20 is going to be the same as not, look, if I put sine of 20, that's not working. All right, that's not working. Because if sine and cosine are ever equal, their values, what did we just say about their angles? They have to be 16. For these two to be equal, their angles have to be complementary. So if I got 20 here, I can do sine of 17. 70. Check it. Check it. Let's see. Sine 70. Yes. All right. So sine and cosine, those ratios are always equal if the angles add to 90. All right, one more for you. Sine of 37. Same value as sine of 37 and 7. What's up? Cosine 53. Okay. Always equal. That's great. That's not honor stuff. Here's where I need you to be with number 3. Number 3, hey, I got 2 angles. First angle's x, next angle's x plus 20. And here's what I'm saying. The sine of angle x equals the cosine of x plus 20. Find x. And by looks, this is what you're going to have a tendency to do. Oh, they're equal, so I'll set them equal. You're not feeling what I just put down a couple minutes ago then. I don't have you yet. I don't have you hooked yet. When are sine and cosine equal to each other? When these two angles are, look, right up here. They're not equal unless those angles are complementary. So they're not equal. They are complementary. They add to 90 when sine and cosine are equal. All right? They add to 90. They're not equal. They add to 90 if I have sine and cosine equal to each other. So my x value here would be 16? 35. And that, watch, that makes sense. Plug it back in. 35, one angle. Other angle would be 55. And what do I know about those two? They're complementary, so that makes sense. All right. We okay so far? Because I'm going to ask questions in a different way, but still using that fact I just gave you. Hey, got triangle ABC here. Triangle ABC. It says C's the right angle, and that's important because as I put angle A and B on my diagram, what do I know about them? They're right? They add. If C is my right angle, A and B must be the ones that add to 90. So it's saying cosine of A is radical 21 over 5. What's the sine of B then? What's the sine of B have to be equal to? Whoa. I don't know why we're touching calcs here. Again, I got to drive this home. Look. Cosine of A. I know the value of cosine of A. If you know the value of cosine of A, what other value do you know then? What's it? This has to be equal to the sine of the complementary angle, which is B. Makes yes? No? Cosine of one equals the sine of the other if they add to 90. What was the cosine of A? Radical 21 over 5. So what's my sine of B? Radical 21 over 5. Yeah, I don't need to do any playing around. As long as they're complementary, cosine of one equals the sine of the other. All right, how about 5? Same diagram. So I know A and B are complementary. Cosine B is 5/13. What else has to equal 5/13 then? Cosine of B equals 5/13. So that must mean what else equals 5/13? 18, thoughts?
Sine of A.
Sine of A, yep. The sine of the complementary angle. Good job. Anything? All right. And then 6, sine of 40 minus x equals cosine of 3x. I get it. Everyone's going to try to do this if we're not thinking here. Right? We're going to do that. Because you just see them set it. No. Look. I have sine and cosine. I'm saying they're equal to each other. I'm saying the sine value equals the cosine value. And then, only time that happens is if whatever's here has to do what? 9. What do I know about those two? They have to add to 90 degrees. I don't set them equal unless the angles add to 90. Okay, you cannot set sine and cosine and equal until the angles add to 90. And when you get it, let me know. Value of x. 8. When you get it.
25.
25. Yep. And then I'm going to let you discuss number 7 on your own. See if we really get this before I call it a day here. If we really get this here. So same diagram I've been using. Angle C is the right angle. If the value of sine A increases, what happens to cosine B then? Go ahead. You guys can chat it up here a little bit. If sine of A increases, what happens to the cosine B? Not the angle, the sine of the angle. Let's make sure I'm not increasing angle A. I'm just increasing the sine of the angle. So the opposite over hypotenuse is getting bigger. What happens to the cosine of B then? My sub question to the actual answer here is, what do I know about these two? Sine A, cosine B in this diagram. Sine A and the cosine of B. What do you know about those two values? 6? The angles are complementary. They're equal to each other, right? These are equal. So if one increases and they're equal, what do you got to know about the other one then? 21? Also increases. One increases and they're equal. The other one has to. So increases. And a good reason is just going to be because sine of A equals cosine B. And I know that was a short one, but that's it. All right, so expect a question or two tomorrow on the relationship between sine and cosine of complementary angles. You be more than happy. Feel free to do these with each other in your group or by yourself. But once it's done, Chromebook out, check the answers. All right, once it's done, Chromebook out, check the answers. Yep. Immediate Chromebook out, check your answers when you're done.